Okay, so up to this point, you've been working on handout 19, I think the first 10 problems. And all of those problems, of course, they give you a probability, they give you Jeannie's going to go do 10 chores, or we're looking at 20 cars, and then they ask various questions. And I'm not sure if you've done those problems numerous times, you've probably caught on to some patterns, I hope, but also the idea that I've only asked you so far what I call the zero case and the all case. That let's say Jeannie had 10 chores. I have not yet asked you what's the probability she forgot 4 of them. So there is a lot of things that I could not ask you, okay, until we do this video. Because there's something I haven't taught you yet. Well, technically you were taught it in 207, but don't worry, even if you don't remember, we're pretty much using the results of something that you learned in Math 207, plus what we've been working on with probability and the word problems from handout 19, and we're going to put it all together into this new thing. The topic for today is called the binomial. Unfortunately, this is not in the book, but most of y'all don't use the book anyway. So let's just kind of recap just a little bit and do a small example, then we're going to do a really big one. Fancy language, right, in mathematics. What you have been working on handout 19, and then also what this video is about, of course, discrete random variables. When you were doing, Jeannie and her chores, she was going to forget and remember them. Jeannie could not forget a half a chore or 2/3 of a chore, right? It was either she forgot 1 chore or 9 chores or 10 chores or whatever. And that's just called discrete random variable. We've only been dealing with the integers, and that's going to continue, of course, in this video. Let's say there's an airline, and some airlines fly domestic, some fly international. Let's say for some particular airlines, 70% of their flights are domestic, 30% are international. We're going to look at the next 3 flights. I have the word calls on the notes, meaning like someone calling in to make a reservation. And we're going to let X be the number of domestic reservations or flights. Okay, we're going to set up a little chart, so this should all look very familiar to what you've been doing. So X is the number of domestics. How many domestics could it be? Well, maybe none of them, 1 of them, 2 of them, or 3 of them. We know all probabilities add to 1. So 0. So again, these first few things I'm going to talk through here really should be review as to what you've already been doing on handout 19. So 0 domestics, well, that must mean they were all international. Remember, I kept stressing, and usually I would sigh in the video, that anytime you had the 0 case, you had to change it. 0 domestic. Maybe I should write that here so we remember that X is representing domestic. 0 domestic is all international. So 0.3 times 0.3 times 0.3. It's 0.027. The other easy guy is 3 domestics. D. 0.7 times 0.7 times 0.7. 0.7 cubed, 0.343. So some of the word problems you've already seen. You may have had to do a complement rule first or something like that, but that's what I mean, that up until this point, everything has been centered around what I call the 0 case, although basically we end up changing it to the all case for international, right? Or the all case. I haven't been asking you any of the other stuff. Well, what if I had asked you about 1 domestic? How would you do it? Well, you'd have to sit here and go through all the possible ways. 1 out of 3 were domestic. Well, which one was it? Was it the first flight? Or was it the second flight? Or was it the third flight? There are 3 different scenarios that satisfy that, right? And from the addition rule, we know that OR means add. So you'd have to calculate all three of these. Domestic, 0.3 times 0.7 times 0.7 plus 0.7 times 0.3 times nope, I already got those backwards, didn't I? See, I'm not using my notes. Domestic, 0.7 times 0.3 times 0.3 plus 0.3 times 0.7 times 0.3 plus 0.3, 0.3, 0.7. Now, if you're savvy, and you're going to need to be eventually, you're going to recognize that each of those is the exact same thing, right? 0.3 squared times 0.7. And there are three of them of the exact same thing. Remember how x plus x plus x equals 3x in algebra, right? Repeated addition is multiplication. So you can go 3, that's just a scratch on my whiteboard, 3 times 0.3 squared times 0.7, that would get you 0.189, okay? And that would be the entry to go there. I'm not going to do the 2 case, but you could do it very similar. The point is, if it's not the 0 case or the all case, doing those cases in the middle take more work. Now, there was only 3 of them. That only took me probably 2 minutes, right? That's not that difficult. What about if I had asked you to look at the next 30 flights, and then we were wondering x equals 12? You're not about to go off to the side of your paper and figure out how many ways to put 12 D's and 18 I's, right? You're not going to go off to the side of your paper and figure out how many ways to grab 12 flights out of the 30 to designate those as domestic. And I've just foreshadowed where we're going with this. In Math 207, you would have studied permutations and combinations. And one of the classic ways to know it's a combination is you're grabbing. We don't particularly care about the order that we grab them in. That is going to be the basis. But I also want to develop a formula for you. So we're going to do one more problem, a little bit longer than this. We're going to develop the formula. The end result, and the good news, is that the formula has been programmed into your TI-83. So you're going to get to save yourself some work, but I want to make sure you understand why it works. All right. Do one more through this example, be a good review, but it's also going to help us develop the formula. Let's just pull Jeannie and her chores again. There are 5 chores. The probability that she forgets any chore is 0.1, and we are interested in the number that she forgets, okay? So I sometimes, 1, 2, 3, 4, 5, 6. I sometimes start to write crooked, so maybe I should go ahead and make myself a grid. 2, 3, 4. Let's see. X, 0, 1, 2, 3. Yeah, I need one more. Okay. Remember, we're doing the number of forgets. This first column is just going to help me think through it. Then we're going to count up how many ways. That should be a pretty thin column. Then what does one of the ways look like? Probability of one of the ways. In the last problem we just did, remember how we had figured out that there were 3 of them? So we multiplied the 0.3 squared times 0.7 times 3. The 0.3 squared times 0.7 would have been what one of them looked like. We had then figured out there were 3 of them, so we ended up multiplying those 2 columns. So those 2 columns together actually equal the probability. But, all right, remember, easiest is the 0 case. 0, or the all case. 0 forgets. Really means all remember. R, sounds like a pirate, right? So remember, forget is 0.1. So remember is 0.9. There's only one way to draw that. Fix my computer here. Make sure you write it like me. This 0.9 to the 5th for the R, I want to write it a little bit on the right-hand side of that space. Okay. The next easy one is 5. 5 forgets. F, 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 right? There's only one way to do that. 0.1 times 0.1 times 0.1 times 0.1 times 0.1. Now on this one, I'm going to write it more on the left side of that space. You'll see why in a minute because I'm trying to develop a pattern. All right, let's spend a little bit of time on some of the harder ones. 1, forget. Which one? Did you mean the first one? Or did you mean the second one? Or did you mean the third one? Or did you mean the fourth one? Or did you mean the 5th one? Usually the 1 case is pretty easy because it really is a matter of position, right? I put the F in the first position, 2nd position, 3rd position, 4th position, 5th position. So I know I didn't forget any. That was pretty easy to stay organized. There are 5 different ways. Now what does one of the ways look like? I have 4 remembers, so that's 0.9 to the 4th, and I have 1 forget. So 0.1 times 0.9 to the 4th. The next easiest would be this. It's kind of like you work your way up to the middle, and the middle's the hardest. Well, 4 remembers. Nope, I'm sorry. I need to really write that this is for F, okay? When I'm here, 4 Fs. It's easier if you think about 1 R. And now you can just put that R in each position. So it's really the exact opposite of what we just did for 1F. You're just putting the R. See, each one of those has 4 Fs and 1 R. There are 5 of them. That is not coincidence. This thing will be symmetric, working its way to the middle. 4 Fs. Each one of these has 4 Fs and 1 R. Now, because this was a topic in Math 207, we do not need to redo everything. Even if you have forgotten it, there's no reason to, spend an entire lecture teaching you that topic over, giving you the big idea. That's a good thing. 2 Fs. It could have been FF, RRR, or it could be RF, RFR, ... Again, this would be an entire lecture teaching you organizational techniques for you to figure out how to make sure you wrote them all down. I do that in 207. I'm not going to do that here. So you can kind of just trust me if you want, or you could go off to the side of your paper. There's not that many. There's actually 10. But if you don't stay super organized, most students get to about 7 or 8. And if they don't know they're shooting for 10, they usually don't get there. So there are 10 different ways to take 2 Fs and 3 Rs. Each one of those has 3 Rs and 2 Fs. And same thing here, 3 Fs. Well, there's one way, ... There's going to be 10 of those. And what does... Each one has 3 forgets and 2 remembers. Now you can kind of see there does seem to start to be a pattern here, right? Let's help out that pattern just a little bit. Look at the 0.9s, 5, 4, 3, 2, 1. Well, we're allowed to put a 1 exponent there. It kind of helps the pattern. We just don't have to write it, but it helps seeing the pattern. But then you're like, well, there's nothing there. Think about it. You could write it as 0.9 to the 0, right? Anything to the 0 power is 1, so I haven't changed anything. And the same thing here, 5, 4, 3, 2, I'll put a 1 there, and I'll write that as 0.1 to the 0. So now it really does look like a very, there's a nice pattern here. Remember how I was interested in forgets, right? And 0.1 was the probability of forget. this generic formula, look, that summarizes the pattern. Here was my probability of forget, 0.1 to the x, 0.1 to the 0, 0.1 to the 1, 0.1 to the 2. Of course, 1 minus p, we already knew was remember, the 0.9. And then, of course, my exponents have to add to 5 to make sure I took care of all 5 chores. X plus n minus x adds to n, right? The total. You could probably figure that out without me developing this whole pattern for you, right? It's always been that column. That's the tricky one. So really quick, Fibonacci numbers, binomial coefficients. In case that column is looking familiar, that's why. But this comes from the combinations. So I'm going to try to use Math 207 notation, if I'm remembering correctly. Combination, I need to grab x out of n. So that's normally how they wrote that. When I teach Math 207, I always like my students to know there's more than one way you will see the combination notation. And another way, especially for the calculators, I mean, sometimes they use an x instead of an r, right? Sometimes you'll see NCX, old school, just in case you're ever Googling or reading a fancy notebook. This might be notation you've never seen. If you ever see big parentheses with an n that seems to be floating over top of an x, there's not a fraction sign there. And there's not supposed to be a fraction. That does not represent a fraction. That is the old school notation for combination. And remember, we're talking about combinations, not permutations. So the total probability equals the number of ways times what does one of them look like. And again, that's what we did on that airline problem at the very beginning, right? 3 times 0.3 squared times 0.7. Well, that's the same thing here. If you take this column times that column, you'll have the total probability. At this point, it still doesn't look like I've saved you any trouble or any time, right? Cool thing is, this formula has been put into your calculator. So let me erase this and we'll kind of get it all together. Okay, so this is the binomial formula. Probability that x equals, what number are you interested in? Were you interested in 0 or 4? The combination term times p to the x times 1 minus p to the n minus x. That's what we just developed on that last problem. Let's make sure we know what the letters stand for. P is the probability of success. Now, success is a mathematical word. It doesn't necessarily mean something was good. In the last problem we did, we were interested in the number of forgets, right? She forgot 0. She forgot 5. The probability of her forgetting was 0.1. So in that example, success was actually the forget probability. And this again, the x is, well, how many did you want her to forget? The number of successes. And n is the number of independent, mutually exclusive trials. This is a formula that only works when there's two choices. Jeannie either forgot or remembered. The car either passed or failed. There's not a third option. Now, on your calculator, because they do require the TI-83 or a graphing calculator for Math 307, everyone's going to need to find where this is. I'll be able to tell you where it is on the TIs. And newer calculator people are going to have an easier time. I'm trying to write out more for the older calculator people like myself. I'll show you where to find it in a little bit. Binomial PDF. And if you're an older calculator person, you have to tell the calculator all the different things. You have to know what order to tell it in. You'll put the N, comma, you'll put the P, comma, then you'll put the number you're interested in. The newer calculator people, it's probably going to ask you number of trials, probability, value or something like that. I think you'll easily be able to figure it out. It's the old calculator people that ours is a bit mysterious. While we're here though, before we go practice a problem, I just like to kind of give you the lecture notes first. There's going to be something else that we use. When we go to our calculator in a minute, you're going to see right below, there's an option called Binomial CDF. Now, unfortunately, that C has nothing to do with the word combination. This C stands for cumulative, okay? Binomial CDF, let's just put in some letters. This adds up all of the PDFs, the individuals, from x equals r down to x equals 0. Cumulative. So let's say I ran the CDF at 5. It would do the PDF at 5. It would do the PDF at 4. It would do the PDF at 3. It would do the PDF at 2. And the PDF at 1, and the PDF at 0, and it would add all of that together and spit out the sum. So it's cumulative from that number, including that number, all the way down to 0. A few more random notes, but I'm not even sure if we're going to get to practicing on this video or if it will be the next one. We are going to have a few word problems that you're going to have to calculate the mean of the binomial. That's pretty much, you want to use very not formal language. That's pretty much the average, which would make sense. If Jeannie had 20 chores and in general she forgets 10 of them, on average she's probably going to forget 2. Or I meant 10%, right? What is 10% of 20? 2 of them. So it makes sense you would go n times p. Standard deviation of the binomial. There's not an easy way for me to get you to understand that formula, so I'm just going to give it to you. The entire thing is under the square root. N times p times 1 minus p. And just a random comment that you're going to see as we do the next word problem. So sometimes you absolutely have to do the binomial because there are multiple ways to do something that requires that combination term. Sometimes you're absolutely not allowed to use the binomial. If it's a precise order and they're telling you exactly what happened, that's just one way and you do what they say. And then sometimes you're going to have a choice. And what do I mean by choice? A choice between using the binomial or using the techniques that you would have done on handout 9, number 1 through 10 already. And we'll try to get that practiced in the next word problem. All right, I just kind of made up a word problem, nothing fascinating. Kind of sounds very similar to what you were already doing before this video. let's say there's 8 tires on the truck. The probability a tire fails is 10%. So with that said, you use whatever word you want. What is the opposite of fails? You could say pass, but a tire passing just doesn't sound right to me. So I'm going to say the probability that a tire is okay is 90%. 10% fails, 90% the tires are okay. That's just the word I'm going to use. All right, let's start with A. Probability that none fail. Right? Let's make sure we know how to translate none. That means 0. Now, before you started watching this video, anytime we had to have the 0 case, we had to switch it, right? Which means the probability they're all okay. So if you put 8 tires in a row and each one are okay, you'd be multiplying 0.9 to the 8th power. So that part right there is review. 0.4305. So that's what I call the old way, before you started watching this binomial video. Well, on this one, you have a choice. So hold on, we're gonna call this the old way. So you could have done it that way, or you could do it the binomial way. Okay, out of the 8 tires, well, let's make sure you know what I'm about to do. I'm going to do 0 fail. The only advantage to the binomial in this case is that the binomial can handle the 0. So out of 8, I need to pick 0 to fail. Probability of fail is 0.1. I need to pick 0 to fail. Probability of okay is 0.9, so that means I have to have 8 of them okay. So here is your binomial formula we put up earlier, right? The CNX, p to the x, 1 minus p to the n minus x. Now, how would you put that into your calculator? You're going to go to the second of distribution, and it's going to pull up vars. I'm going to talk through it, then I'll grab the calculator. For the old, and then you're going to go to Binom PDF. And if you have an old calculator, once you select it, it's going to sit there and blink at you. And I'm so sorry, I see a cat coming. Oh, no, he's gone the other way. Okay, so let's pick up our calculator. Oh, it's out of reach. Hold on. Okay, so you got to find your vars button. Okay, go to the second function of vars. We'll pull up that distribute. Oh, I wrote that backwards, didn't I? This is what I get. I wrote it right on the notes. You should always go with my notes. Second of vars pulls up distribution. Okay, pulls up distribution. Don't stop at the normals. Scroll on down. On mine, it's number 0. Okay, it says Binom PDF. When I select it, again, if you have an older calculator, yours is going to be blinking just like mine. And you're like, well, what do you want from me? Well, I had to Google it one time, or you have to look in your manual. So old calculator people, you have to do the N, comma. Commas are critical. Now, here's where I hate when we have to memorize things, right? I've always called this pick a pair. See how in your formula there was 1 pair? Well, you can just write the pair there. You just have to put a comma in between it. 0.1, comma, 0. So, if you're thinking ahead right now, you might be saying, can't you do it the other way? You could do binomial PDF of 8, comma, 0.9, comma, 8. If you wanted to pick that pair, 0.9, comma, 8, they are going to be exactly equal, right? Because 0 fail is all okay. That's what this stuff is representing. This one's representing 0 fail. This one's representing all okay. We've already talked about how those are synonyms of each other. So hit enter, and you're going to get 0.4305, which we were supposed to. Again, new calculator people, I'm trusting that you'll be able to understand what screen comes up next. If there's any issues, absolutely email me. All right. So basically, when it's the 0 case or the all case, in this case it would be 8, right? You're going to have your choice. You can do it the old way, or you can do it the binomial way. I think the binomial way is absolutely overkill. But I find every time I teach this in Math 307, after you guys have a little practice with the PDF and your calculator, most of you want to go there. So it's entirely your choice. There were 2 ways to do this problem. All right, let's go on to part B. How about probability? I erased a little too much. Fail was 10%, okay was 90%, and we had 8 tires. Okay, probability, only the left front fails. I don't know. Sometimes when you go to the mechanic, you have to describe where on your car the problem is. So, if there's 8 tires, the idea that I'm trying to describe and tell you I know exactly which tire failed. This is not saying what's the probability one of them failed. If you could picture a truck with 8 tires right now, then you could go and point and say, oh, that one failed, which means the other 7 were okay. So this is what some of you guys call distinguishing order, specific order. Some people say, oh, that's not vague. I know exactly what they're telling me to do. Whatever you want, that means you cannot use the binomial, because the binomial is more vague. It doesn't know which one you're talking about. No, I know exactly which one I'm talking about. So that left front, that 1 tire, he failed, which means the other 7 were okay. So this you've already done before you started watching today's video, right? We had a couple of those on handout 19 already. And if you hadn't picked up when you've been doing handout 19, your exponents always have to add to the total 8. So I just wanted to review this because this is a case where you don't have a choice. You cannot use a binomial. All right, how about part C? What's the probability exactly 3 tires fail? Now, I have learned through the last 15 years there is no English word that every student is happy with. I used to simply say, what's the probability 3 tires fail? Students were not clear on that, on whether I knew which 3 or not. Or if I even meant more than 3. Because like if 5 failed, then doesn't that mean 3 fail? I'm like, no, that's not what I said. So I started using the words exactly, or I started using the words just 3 fail, or exactly 3 fail. But then I have other students who think when I use those words that I'm trying to tell them I knew exactly which ones it was. And I'm just trying to say it wasn't 2, it wasn't 4, it was 3 tires fail. Okay, you gotta let the really big, obese, fat cat walk by. Let me help him so he doesn't knock the plant off. Okay, he was my success story. He was a feral, unneutered cat with holes, streaming blood in his body. Took me 9 months, got him to trust me. Now he's a lazy house cat. But I digress, right? Okay, 3 tires fail. Which 3? Did you mean like the 3 on the front? Did you mean 2 on the front and 1 in the back? Did you, the again, there's no way I'm going to go over to the side of my paper and try to figure out all the ways to grab 3 tires from 8. So this is where you must use the binomial. Okay, out of the 8, I need to grab 3 that are going to fail. So the probability of failing is 0.1, and I know I need 3 failing. But I got to take care of all my tires, right? There's 5 other tires. Oh yeah, the other 5 were okay tires. But again, we have a quick formula or, programmed into our calculator that's going to do that for us. So you can run the Binomial PDF. You can run it 8.1, 3. Again, the commas are for the old calculator. Or you could write it as 8, 0.9, 5. No matter, you should get 0.0331. Okay. So that was a case where there were multiple ways, absolutely had to use a binomial. So that's kind of like the new stuff of why this video is being made. Let's go do a D. Probability at least 1 fails. Okay. Thinking through the old way, well, I'll review in case you've been struggling with handout 19, because I know the word at least is the one spot that most students get tripped up. Okay, so this is the number that fail. That's my probability. Remember the old way I told you only had to write the first 2 and the last 2. At least 1 means 1 or more. So here's a little review. We wanted that. And we're like, oh, that's too much work. So let me go 1 minus what I did not circle, which is 0, fail. Then we would always sigh, right? And I'd say, oh, I have to do all okay, which is 0.9 to the 8th. Which, if you keep going, it's 0.5695. Now, just like, I guess it was part A, at this point, from right here, your binomial can deal with 0, right? You could go 1 minus binomial PDF. I had 8. Probability of failing was 0.1, and I needed 0 to fail. So you could go right here to right here. I promise you, you'll get the same answer. So this is one that you have a choice towards the end, right? All right, let's do E. Yeah, E's a little bit trickier. We'll get to practice that CDF now. Probability that less than 3 fail. So you just want to kind of think in your head. First of all, you need to translate, what does less than 3 mean? Well, that means 0 fail, don't forget the 0 case, or 1 fail, or 2 fail. Not 3, because it said less than 3. If it had said no more than 3, you'd need the 3 case also. So be very careful as to the definition of those English words, right? And we know that or means add. So technically, you got 3 things to do. You could go do 3 PDFs and add them up. Actually, that guy, you could just do it the old way, right? 0 fails, all pass. You'd have to run a binomial there. You'd have to run a binomial there, add up those 3 numbers. On this problem, there's probably 4 different ways to do it, and you don't need to watch me do 4 different ways. So I was just trying to ramble that if you're thinking, oh, I could do it like that, absolutely. But this might be the perfect example of the CDF, because if you run binomial CDF, again, old calculator people, we're talking about, well, n is 8, right? The total. We're talking about failing, so we're using 0.1, and you put in a 2 here. This formula is going to add up the PDFs at 0, 1, and 2. Now, before we grab our calculator in our hand, I can tell you the most common mistake. People see the 3 here, and they see the less than 3. So they do think about the CDF, the cumulative binomial, but they forget that less than 3 means I wanted to start at 2 downwards. So you have to run your CDF at 2, because by definition, it's right, it's who's programmed your calculator. By definition, the CDF is going to start at the 2 and then work its way down. That is exactly what I wanted. So you're going to go to the same place. Go to second of vars, it pulls up Distra. Remember how, at least on mine, 0 was PDF? Right below it, you should see CDF, okay? So you just got to really be careful when to pick the P and when to pick the C, since they're right next to each other. Go ahead and do that, and you will get, what do you get? 0.9619. All right, let's throw one more piece on here. Probability at least 5 fail. At least 5 means 5 or 6 or 7 or 8. So again, there really are lots of different ways you could do this problem. But, I mean, you could just do your 4 separate PDFs, add them up. Technically, that doesn't need a PDF. You could do it, but 8 fail is just 0.1 to the 8th. So you could do your 3 PDFs, add them up, plus 0.1 to the 8th. There is a way to make the CDF work, though. Because think about, let's just draw a quick picture. Just so we can visualize this. This problem is asking me for that, right? So, oh, I'm already actually seeing another way. Maybe I'll hold off on that for a second. I'll keep to my notes. If you run, think about it. If you run the CDF at 8, it's the CDF, right? It's going to take the 8 and the 7 and the 6 and the 5 and the 4 and the 3 and the 2 and the 1 and the 0, all those PDFs. It's going to add them up for you. Well, that's not what I wanted. I only wanted 5 through 8. I didn't want all of that. So, you could then subtract the CDF at 4, because the CDF at 4 is going to be 43210. So yes, I'm going to end up with what I wanted. I want you to run those 2 CDFs right now, even if you have to pause me for a second, okay? All right, I assume you're back. You may have caught that I overkilled something, but I did it on purpose. I wanted you to realize for yourself that that first term is 1, and it has to be, right? If you're doing the cumulative, you're adding up all the probabilities at every possible x, right? That all probabilities add to 1. So I wanted to make sure that you understood that, of course, the CDF at the total is 1. All probabilities add to 1, the unit whole. The other guy is 0.9996, so you end up with 0.0004. Now, when you were drawing this picture, right, this would have probably helped you realize how to set it up. Because you've been like, oh, a lot of times when we circle stuff, we do a 1 minus. 1 minus, what did I not circle? Oh, the 0 and the 1 and the 2 and the 3 and the 4. Oh, great, that's a CDF at 4. right? So that's another way to visualize why this formula is working. And that one is of course when you run the CDF at the total. So lots of ways to think about this one, lots of ways to do it. I mean, you could have just gone from the beginning and done the individuals and added up. No matter what you do, you should be getting 0.0004. I think that's probably enough for one video. Also, I'm always afraid to make too long a video that then somehow, as it goes to YouTube, it will get messed up. So I'm going to make another video and you could watch it immediately. But in case you're going to take a little break at this point, you should be able to do the rest of handout 19, except the ones that talk about mean and standard deviation. Because the problems that need you to calculate the mean and standard deviation will be the video you watch right after this. So just kind of helping you stay organized in case you wanted to practice some homework first. You should be able to do the rest. Just skip those. There's usually like part C or part E of a problem. Then after you watch the next video, which will be more practice, but we'll also practice that. Okay.